GPS in flight. Fifth lesson. Hello everyone, today we will cover the last lesson, flight planning and navigation with GPS. Mounting the GPS module on the drone.
In our next content, we will connect our GPS and then proceed with the installation of our remote control receiver and telemetry. Yes, we continue our assembly from where we left off. We had completed the installation of our Pixhawk. Now our next installation is the GPS mount. Before placing the GPS stand, the most important thing to pay attention to is that our GPS and Pixhawk are facing the same direction. All right, so let's proceed with the installation accordingly. We had already adjusted the holes where the GPS stand will be mounted. Now let's quickly complete the installation in those holes. We have completed the connection of our GPS mount. Now it's time to mount our GPS. We are threading the cable properly to mount the GPS. Threading, threading, threading. After properly threading the cable into place and aligning the clips, we will look at the bottom part. For this, we turn our friend like this, and we attach the screw. And that's how easy our installation is. We've completed the installation of our GPS. Next, we'll make the cable connections for our GPS. Since our GPS supports the CAN module, we'll use the inputs that utilize the CAN port. According to the paper I have, we'll connect this cable of our GPS to the CAN 1 port and this cable to the CAN 2 port. And that's it. We've successfully completed our simple GPS installation.
We have established the GPS connection of our drone. Now we move on to GPS calibration. We have established the GPS connection of our drone. Now we move on to GPS calibration.
We have come to an open area for the calibration of our drone. The reason we are in an open area is that our GPS cannot function properly indoors. To start our recording, we connect our drone to the computer. We connect the Type-C cable, which we have attached to our flight control board, to our computer. After establishing our connections through our computer, we connect to our unmanned aerial vehicle at a baud rate of 1V2200. After receiving the parameters, we go to the compass menu from the setup screen for compass calibration. Once on the compass screen, UAVCAN represents our GPS that works with the CAN protocol. To calibrate it, we press the Start button under the MAC calibration section below. Now, after pressing the Start button, as you can see, the lights on our GPS are flashing in yellow, blue, and green main colors in a flip-flop manner. Then we rotate our drone on 6 axes. While performing this rotation, you can also observe that our panels are filling up in green on the computer. As these panels fill up, our compass calibration is completed. First, we rotate our compass fully on the horizontal axis. Then we rotate it on this axis. Finally, we rotate it on this axis as well. After rotating our drone nicely on all axes, our compass calibration is complete. The reason for calibrating the compass in this way is that it operates based on magnetic logic. After the green bars on the screens fill up, our light starts blinking yellow. Then we reboot our autopilot. That means we restart it. Here we press the reboot button and click OK, and our autopilot restarts. After rebooting the autopilot and reconnecting, our compass calibration is complete. Once the compass calibration is done, you will see that our GPS has a 3D fix on the flight data screen. That's it for the compass calibration. Now we will set the flight conditions, and accordingly we will be able to configure the failsafe for our unmanned aerial vehicle.
We have completed the calibration of the GPS. Now we will create the flight plan and assign missions to the drone.
In the planning section, our drone is already visible here. We will now add points and stops around its current location. For example, let's have our drone move to this point first. Then it will move to the H mark here, then to this spot, and finally, it will come here. At the fourth position, instead of calling it a waypoint, we will assign a land command there. This is where it will land. Okay. Now we've specified the landing location. In the other parts, the altitude is shown as 100 meters. This is not ideal. We are adjusting our waypoints to 7 meters, which is ideal. Okay, now first, we will manually take off the drone. Then it will autonomously move to position 1 after takeoff, in position hold mode, and autonomously land. This is another feature of autonomous customization. When we write it from here, it will be saved. Our autonomous mission is now uploaded to the drone. When I write read, ignore the read part. Now, when I go to the config section, we can see how it will move autonomously in the extended tuning. We should be able to see this from this part here. It's given in centimeters. It's a bit high. Let's make it 500, or even 300. Yeah, let's not get into trouble. We also save this parameter. Other than that, there's nothing else about the drone's movement. Alright, we drew and printed our observations and project from the data and planning sections.
Now we've come to the data section. From this point on, we can start our drone's flight. We are currently in position hold. I lowered the throttle to the minimum position. I'm arming. We climbed to an altitude of 7 meters. Now I'm switching to auto. Yes, the drone is moving. Yes, nice. We have completed our 5th and last lesson. Thanks to these lessons, we learned what GPS is and how and for what purpose it is used in aircraft. Thank you for being with us in this process.